All right, so what we're going to do is find the area of a region that is defined in polar coordinates. So we have here the area enclosed by r equals 2 minus cosine theta, which is shown to the right. And the thing to realize, as with most of these functions, since they are trig functions, is that we sweep through the entire curve between 0 and 2 pi. Okay, and that is the case here. You can always check that with a graphing utility as well. So we know that area is equal to 1/2 times the integral from start point to end point of whatever r squared is d theta. So it gets swept out in terms of theta. So I'm looking at this, if I start at the origin and just pick random, as theta increases, I notice that the length of the segment is just whatever from 0 to r is. So r is just going to be what it's stated to be, r 2 minus cosine theta. And then from here, the work begins. So we multiply out. So it's going to be 4 minus 4 cosine theta plus cosine squared theta. And yeah, I'm still dragging on this 1/2. So we have 4 minus 4 cosine theta. Now, cosine squared theta actually is shown in this identity right up here. We always need to replace it with the double angle identity. So this is going to be 1 plus cosine 2 theta over 2. And then combining like terms, I'm going to do that piece. Whoop, so that's 0 to 2 pi. Can't forget that. So we have 4 plus 1/2, which is 9/2. We have minus 4 cosine theta. And we have 1/2 cosine 2 theta. And now we integrate that. So we have 1/2. So the antiderivative of 9/2 is 9/2 theta. The antiderivative of 4 cosine theta is 4 sine theta. And the antiderivative of 1/2 cosine 2 theta is, well, so the antiderivative of cosine 2 theta will be sine of 2 theta over 2. So that becomes over 4. And that gets evaluated at 2 pi and 0. And I'm just going to squeeze in the answer here. So when I plug in 2 pi here, that becomes 9/2 times 2 pi, which is 9 pi. Half of that is 9 pi over 2. Sine of 2 pi is 0. Sine of 4 pi is 0. And then when I plug in 0 to everything, all of that is 0. So the final answer is 9 pi over 2. And that's all there is to that one. Next one, we'll look at the area of the region between two polar curves, because that's going to be a little bit more interesting. So stay tuned. Thanks for watching.